Hi everyone, my name is Kosti Vasilakakis and I'd like to welcome you all to the AWS Tech Talk on how to do faster data preparation for machine learning with SageMaker Data Wrangler. I personally lead the global go-to-market strategy and product growth strategy for what we call low-code, no-code machine learning. And today I'm accompanied by my technical counterpart, Arun Shankar. Arun, who is going to be actually doing the majority of the show. Do you mind introducing yourself as well?
Hey everyone, this is Arun Shankar. I'm a machine learning solutions architect with AWS. I've been working for AWS for more than 2 years now, specializing in SageMaker. Today we'll be focusing on SageMaker Data Wrangler, which is one of the low-code components within SageMaker. Glad to meet you all.
Awesome. Perfect. Thank you, Arun. And quick level setting on the expectations. We will be going over through, first of all, an understanding of why scaling machine learning initiative is troublesome for many of the companies that we are working with, and how low code, no code machine learning capabilities help them really accelerate the experimentation as well as the productionalization of the machine learning models. And it's not only for what we call novice data scientists, but also the experts out there. And then we'll go deep into what we hear from our customers takes more than 80% of their time, which is feature engineering and data preparation. And we'll go through what are the key pain points that we've been hearing our customers speak about, and how we've built Data Wrangler, which is a visual data preparation technology, to really help solve for those pain points. And then we'll dive deep into a demo and the different capabilities that it offers. And in the end, we'll go through a live moderated Q&A through the chat below. So wherever you see that, be it in the platform we offered or LinkedIn or YouTube, feel free to use the Q&A boxes, because we have moderators actually reviewing all those and responding to you instantly. So you don't have to only ask questions on the last 10 minutes. You can go through and ask questions throughout the session. Feel free. So going towards how machine learning drives value creation today, and it always actually starts with certain set of business requirements. So the business teams are coming in and saying, listen, I would like to predict my inventory that I should be having. I would like to predict what is the churn that we will be facing, so that I take some preemptive actions, or what is the expected sales conversion, and of course many more, with a lot more nuanced and a lot more complex use cases that might involve natural language processing or text, or might involve images and else computer vision. So the business teams usually come in and ask a question, especially to the data scientists, to the data engineers, ML engineers, and saying, can we predict that? And of course, the data engineers and data scientists hear all the different needs that the businesses have, and they go and prioritize those based on the impact that they will have in the business teams, as well as based on the complexity to collect the data and build those models or productionalize those models. And based on those trade-offs, they usually prioritize, and they start through going through the data preparation, collecting all the data sets from all the different data sources that they have, then going through cleansing the data, standardizing, consolidating them, and eventually doing what we call feature engineering, depending on the different types of models that they want to experiment on. And then they go through what we see as an iteration of model development, training, and tuning, and going back again to feature engineering, collecting and cleaning more data, or better preparing the existing data sets they have to feed them into existing or even new models, and go through multiple times so that they find the best ML pipeline for this particular use case that they want to focus on. And then they go into productionalization of that model in using traditional MLOps techniques and deploying it into a certain set of inference endpoints. And that process, of course, gives back an experience to the business teams or directly embed this experience to the product itself that this company has, and gives an ML powered prediction or an experience based on the requirements that the business team has dictated. But because this process is very tedious and resource intensive, we've been hearing from our customers that it takes weeks or even months to actually bring back into production a use case, a prioritized use case. And unfortunately, it doesn't solve for all the possible use cases that the business teams have, but actually urges them and makes them focus only on the prioritized ones. So the question usually is, how can our business teams and the technical teams really scale the machine learning that they have? And it boils down to this common set of challenges that they have to solve for. And first of all, they say that ML experimentation is really time consuming and it requires a big set of expertise. They need to know how to deal with data, feature engineer, how to build models, how to train them, tune them, productionalize them. But they also say that 80% of that time is actually spent in consolidating data, in doing what we call exploratory data analysis, and then doing feature engineering on top of this data. And that is a very iterative process that really requires expertise of the end-to-end machine learning pipeline, but also of what exactly feature engineering is required based on the different types of models that are to be selected. And then we hear that data science teams are really oversubscribed. And for our data science out there, it's your needs in terms of the requirements and use cases are only increasing, which is a healthy thing. But we have heard that the demand of use cases and problems are actually scaling a lot quicker than the data science teams themselves. And we also hear that, okay, how about we leverage another persona to solve for machine learning requirements? And unfortunately, machine learning is not that easy, and it requires a lot of understanding, technical understanding, mathematical understanding, and learning curve is quite high. So tapping into the business analyst hasn't been traditionally a solution to this challenge. And what we hear is that ideally, they would like all the stakeholders that are participating in the ML value creation to collaborate a lot faster, from the business teams, be it business analysts, to the data engineers, to the data scientists, to the ML ops teams. They need to be able to collaborate a lot quicker, reduce the friction and the overhead of the handoffs, and be able to enable those more technical personas. And for this reason, we came to market with a certain set of capabilities, and we are asked, how can we help you as our customers scale the machine learning value creation? And of course, one of the ways is to expand your machine learning development team. But we also heard that this is actually not easy, because to expand the team using machine learning engineers and data scientists is really not that easy, because the past 4 years, the annual compound growth of this particular set of skill set in demand is 74%, so which is twice as fast as any other profession out there. And the other solution that we say is that you can actually enhance the machine learning team productivity. And for this reason, we came to market with low code, no code machine learning capabilities to really enable those personas to tap into a set of tools that can help them do their job much faster. But not only that, we've came out to market with a solution to democratize machine learning innovation. And we have a lot of assets out there speaking about how you can give business analysts a set of capabilities, and more specifically, SageMaker Canvas, to help them get a no-code machine learning experience without them knowing anything about machine learning. They can now tap into the predictive power of machine learning. And this amalgamation of those two offerings in terms of enabling the data science teams do their job much faster and enabling the business teams and more specifically business analysts to tap into ML is what you see on the screen. On the business teams, we offer SageMaker Canvas, which is the no-code machine learning experience dedicated to people that have zero technical expertise. They know their data, they know their domain, but they cannot write code, or even if they can, they prefer not to. And we give them a very nice and easy visual interface to aggregate different data sets, prepare those data sets, and then we take care of building machine learning models completely automatically, and we give them back something that they can understand, and a visual UI that is easy to use and with visualizations and metrics that can be understood by the average person. But we also offer data science teams three capabilities, which one of them will focus a lot more today. Data Wrangler is our visual way to aggregate and prepare data for machine learning. Autopilot is our AutoML capability that takes care of tabular and time series data and completely automatically creates feature engineering, creates pipelines of feature engineering, models, and hyperparameters to really give back to the user a fully white box experience of the best performing model. So we give back one performing model as well as its code that is supporting it. And Jumpstart is actually what we call a model zoo or a zoo of solutions, which our data scientists out there can leverage the GPT-2s or BERTs, Robertas of the world as is, or by doing transfer learning or by fine tuning them. So very quickly, via visual UI or through an API, can access hundreds of different models for NLP and computer vision that they can either use as is or find using their data, and in a way get access to a lot quicker iteration on top of those state-of-the-art models. But as mentioned, today we'll focus a lot more on what we call Data Wrangler, which is our visual data preparation and feature engineering tool that Arun will walk us through in a lot more depth. So Arun, go through a little bit of high-level understanding of what is Data Wrangler, and then maybe we do a live demo so the team can understand a lot more what the real beauty and the real power of Data Wrangler.
Thanks, Costi. Okay, perfect. So Costi basically, gave a little heads up on what we'll be focusing today, right, in this session. So before we get into the demo, let's look at some of the common challenges in data preparation. So if you look at the slide on the right hand side, you can see this sort of 100-foot overview of the process of data processing. Now in data processing, obviously you would have to start with data collection, right? So once you collect your data, then you could basically fork off data preparation into two big stacks, right? So one is data pre-processing, the other one is feature engineering. So feature engineering is a little bit more advanced. It is very specific to the machine learning pre-processing you would have to do to get your raw data set into an ML ready state for training and tuning. Now within data pre-processing, you can see there are several several layers. So starting with cleaning your data, partitioning your data, normalizing and standardizing your data, fixing the bias in your data, right? So you would have to detect and mitigate the bias that exists within your data. Also, it covers data augmentations. A lot of times you would have to work with data to see if you can morph the data or change the data, right, in some dimensions to make it a better fit for machine learning. But let's go over some of the common challenges. So one of the most frequent and most popular challenge with data is, how do I go and gather or grab data from disparate data sources, right, and combine them into one unified standard format so that I could start all the downstream ML activities, right? So that's the most common challenge. So how do you get data from different sources, and how do you convert or transform all these different data formats into a unified form. Deriving new forms of data. So when we say deriving new forms of data, a lot of times you would want to take your raw data or raw feature columns and see if you can apply some transformations on it to create more columns, or maybe just create a different column right in place. So this is deriving new forms of data. This is really important for machine learning. So that's again a very common challenge. On the other hand, you also see a lot of anomalies, right, and problems with your data sets. So these are basically red flags in your data set, things like missing value, things like columns that are being duplicated, right? Or maybe data columns that are not following a very specific data type. So it's a mixed data type column. So these are really red flags, and this is going to break a lot of things later. So we would have to fix all these erroneous values upfront. Then we get to the part of how do we support different personas within this machine learning landscape, right? So a lot of times not only data science are going to be involved, but you're going to be working in hand with data engineers and other personas, right? Data analysts. Now how do we make the process seamless so that you can do better collaboration across these different personas? And then let's say we do go and finalize, right, all the different steps we want to do for data preparation. Now how do I take all these steps, right, in a sequence and fit that into an automated pipeline that can be productionized? So, and now when you're starting to think in production, scale becomes a big factor here, right? So we've been doing a lot of things in an experimentation mode, but now to get that to prod, we would have to make sure that you would have to scale a lot of the steps, a lot of the algorithms we employed for these data processing. And then the most important part is actually the right sequence of actions. So a lot of times, because this process is overall very cyclic and ad hoc, we would have to make sure that we arrive at the right sequence of actions, right? All the way going from collecting your data, pre-processing your data into, and then doing feature engineering right on top of your data, and then getting the data to an ML ready state, which can be directly plugged into model training or model building. Now let's see how data Wrangler basically fits into this problem and how it helps us solve some of the common challenges. Now with data Wrangler, you can connect to a data source, not just a data source, but you can connect to a lot of different data sources that we support. So we'll see that in the upcoming slides. So we support multiple data sources, and we also support multiple different data formats, right? So you can basically import data from these different data sources in different formats and bring that all into an unified experience. Number two, data Wrangler also offers um, a set of pre-built analysis and transformation options. So when I mean analysis, one of the first steps in data preparation is exploratory data analysis. So you're going to basically pull in your data and start looking at your data right in different angles, looking for anomalies, looking at the distributional kind of statistics, and looking at various other aspects right of your data set to make sure that you should be taking the correct steps when you're getting into the feature engineering side of things. So we offer a pre-built a list of analysis and visualization options that you can choose. On top of it, we also give you 300 plus different transformation strategies that you can apply on your data to convert your data to the right format and the right state, right? So this is feature engineering basically. So ML specific feature engineering that we support out of the box, which you can basically choose and apply on your data sets, right, within the visual editor. And then the last piece is, okay, now I've I've done all this visually, right, in a tool driven fashion, which is basically importing data sets from different data sources, formatting them, standardizing them, doing some exploratory data analysis, right? Figuring out the correct set of transformations I want to apply, and then going and choosing those transformations. How do I take all this recipe or all these steps and productionize? So that's where we offer again a native support for integrating with other services like Feature Store. Also native support to take your recipe, which you did again right using a sample in an experimental mode, and then scaling that out into large scale distributed production grade jobs that's going to make sure that the pipeline that you build becomes more robust and it can be automated in the long run, and you can apply it on a larger scale data. So as I mentioned, we support multiple data sources. So we support Amazon S3, Athena, Redshift. We also support Snowflake and Databricks. Plus, you also, you have native integration to SageMaker Feature Store, which means you could basically take your processed or transformed features and ingest it directly into SageMaker Feature Store without writing any code. Now, some of the most common file formats we support CSV, Parquet, JSON, JSON lines, ORC, database tables. Plus, we'll be supporting, more data sources and data formats right in the future. So now we will look into, some of the exploratory data analysis and, some of the options for data transformations in the demo, right? We'll do a little more deep dive. On the very high level for exploratory data analysis, we offer a set of visualizations that you can use, basically, with a few clicks. We also give you options like data insights or quick insights, where as soon as you import the data and bring it into the interface, data wrangler interface, we're going to go and run some of these analysis automatically behind the scenes and give you these insights and reports, right, for you to actually take a look at. So this will give you the prescriptive actions you would have to take in order to make the data set more robust and more ready for machine learning, which you would be doing at the later stages. Now, for the transformations, we support more than 300, and this list of data transformations is growing like every day. So things like advanced ML specific transformations like one hot coding. So I have categorical, feature columns, and how do I deal with it, right? Do I want to do ordinal or one hot? Now, do I want to vectorize text? Do I want to balance my label column? How do I handle outliers? Now, let's say, I don't have the transformation I'm looking for in the 300 plus built-in transformations that we offer. You can obviously bring in your own custom transformations in the supported frameworks, which is PySpark, SQL Pandas, and native Python UDFs. We also support a lot of transformations in analysis type that are specifically targeted towards time series. So things like peak detection, peak counting, detecting the trends within your time series data, and also applying Fourier transforms right on your time series data. So we covered like EDA and all the different transformations you can do. But the last step, and the most important step, is now how do I take all this and productionize, right? Go to my production state. So that's why we offer again one-click jobs where you don't have to again write any code. Instead, you can create something called a destination road or destination sinks, where you can go and say that I want to take the output of the pipeline that I've created visually through Data Wrangler and create a sink for this pipeline, meaning I want to export the transformed ML ready data set directly to a sink. So right now we support S3 an option, but soon we'll be supporting SageMaker features too and other forms of output locations where you can go and actually park the output of the pipeline that you've created. We also allow you to go and export the pipeline as a notebook. So you can basically take all the steps that you've created in the visual interface and convert that into runnable, executable, Jupyter notebook code, right? Which is Python code. You can also export it as pure Python script if you wanted to, if you're not familiar with like notebooks. We also give you an option to go and take the feature engineering pipeline that you've created and um, put that into a pipeline that can be orchestrated, right? So we integrate with something called SageMaker pipelines, which is a different component that lets you take this pipeline, feature engineering pipeline, and integrate it, into a more end-to-end pipeline that could be leveraging, training and deployment, other parts of ML lifecycle. So that is again, supported natively. And as I mentioned, we also allow you to go and take the output of this and publish directly to SageMaker Feature Store. So given we know we have seen a lot of high-level details, let's get into the demo now and see a nice use case for the travel industry. For this demo, we'll be using the SageMaker Data Wrangler Deep Dive Workshop. So we have shared the link to this workshop in the form of both URL and QR code. So you will be getting all those resources at the end of the session. So please follow the URL to get to this workshop for Data Wrangler. And here, to replicate the demo, what we'll be covering in this session, one of the first things you would have to do is set up SageMaker Studio and set up a user, right, user profile within SageMaker Studio. So if you go to the prerequisites section here, we're going to be this is going to be including all the instructions that you need to set up SageMaker Studio and set up a user profile, to allow you to get started with Data Wrangler. So today we'll be covering a nice use case for the travel industry. So here, if you click on use case under getting started, you can basically scroll through and read what this use case is about. But let me give you a little context on this use case. So in the travel industry, right? If let's say if you're a travel booking website, something like Expedia or Priceline or Bookings.com, it is really important to make sure that you take all your historical data and have and kind of create some insights into why people cancel bookings, right? Because that's this is an industry where the churn rate is extremely high, so there are a lot of cancellations happening all the time. So if you're in industry, if you're in the business for, let's say, quite a few years, you can go back and look at the historical trends, right, of all the different aspects of a user, why he booked a particular hotel, what were the most important factors like that led him to actually reserve a hotel, or any other entity. And then also, what are the most important factors that let that user cancel that reservation? What led him to cancel that? So these are important things that the travel industry always wants to understand. So for this use case, what we'll be doing is we'll be picking a data set, right, from Kaggle called the hotel bookings data set. And this data set basically has 32 columns. So one of the columns that we're trying to predict here is whether a user would cancel a reservation or not. So making an assumption that this data set captures all the reservations, right, historically that happened with a resort or a hotel. And we want to go and actually look at some of the factors or some of the feature columns in the data set and see if we can come up with a predictive model that will let us know whether a particular reservation will be canceled or not. So to download this data set, you can go to the Kaggle link and download it. So that'll give you a CSV file. Now I've already downloaded the data set and uploaded it to an S3 location. So that's also a prerequisite to get started with the demo for this session. Now let's head back to SageMaker Studio and see how to get started with Data Wrangler. And also let's see how to import the data set which we uploaded to S3, the data set that we downloaded from Kaggle. Let's see how to import that data set from S3 into Data Wrangler, and let's see how to do some exploratory data analysis first, followed by feature engineering, and then other things later. Now, once you get to SageMaker Studio, what you will see is this launcher. So this is going to be your entry point for SageMaker Studio, and here you're going to be seeing these different swim lanes. Now you can create Data Wrangler. You can launch Data Wrangler, right, in several ways. The most easiest way is obviously come here in the first swim lane, right at the the last option. You see SageMaker Data Wrangler, so you can hit Start Now. So that's one way to do it. As soon as you hit Start Now, you'll see it launches a flow file, right? So this is basically the file that's going to be capturing all the things we're going to be interacting with Data Wrangler. So let's give it a name. So I'm going to name it Bookings Demo. Now let's go and actually import the data set from S3. So I'm going to go and click on S3, and then so you'll see this S3 file browser. So I'm going to navigate to the bucket where I have my data set. So here I'm going to navigate to the folder datasets where I have the bookings.html hotelbookings.csv, so which is the file that I uploaded. And as soon as you click on it, you can see you're going to get a preview of the data set here. So you can scroll through and look at all the different feature columns. But on the right-hand side, right-hand pane, you can see there's an option to go and random sample your data set. Now this data set has more than 120 rows. We don't want to import all the 120 rows for exploratory data analysis, right? So for the sake of brevity and to keep it lightweight, we're going to go and import random 10,000 rows from this data set. So you can go and choose the sampling type, change the sample size. There's also a lot of other things you can change depending on your file type and whether you have a header or not. So I'm going to go and import this data set. Now, as soon as I imported the data set, you can see it starts creating this flow diagram. So you see two blocks here. It says that we sampled initially a data set that we imported, and then automatically it's able to detect the data types for the data set.
That's perfect. And you mentioned like exploratory data analysis. What do you advise our users out there to how do you advise them to start with, and what options do they have in exploratory data analysis that is prepackaged within Data Wrangler?
So probably it's the right time to get into analysis. So let's look into how we can do some EDA on the imported data set. So we'll start with looking into the automatic data insights that we offer out of the box. So one way to go about it is you can go and actually click on it right here. So when you click on it, you can see it takes you to the analysis page where you're going to see that it's asking you to choose the target column. So in our case, it's the is canceled, right? Whether the booking is canceled or not. So you choose the target column and you say that it's a classification problem. Basically, it's a binary classification problem. And then you can create the automated data insights, which Data Wrangler offers out of the box. It's going to take a couple of seconds. Okay, so you can see the data insights it's done. So one of the first things you get from data insights is the dataset statistics. So you can look at things like what is the proportion of missing values, how many duplicate rows. We can see almost 17% of our data set has is duplicate rows. We also give you the breakdown by the feature type and how many columns, right, of that feature type we have. If you come down, one of the most important things we get out of data insights is the priority warnings, high priority warnings. So you can see that there's two big issues with the data set that we really need to fix. So now data insights is going to go and actually explain that here, and also right at the bottom it says what exact transformations you would have to apply when you get into the feature engineering side of things. Now for duplicate rows, it says 17% of the data is duplicate, and to fix this, you would have to go and apply the drop duplicates transform under manage rows, during feature engineering. So we'll do that once we get to feature engineering. It also says there's target leakage, meaning there's some column in our data set that directly correlates with the target label, and it's going to basically mess up a lot of things, right? So we'll end up basically creating a model that is completely misleading. So we would have to go and actually fix this target leakage, which means we'd have to go and drop the column that is actually a target leakage. So in this case, it's actually the reservation status column. So these are some very interesting insights you get out of the box, and you have to make sure that you fix this by following the prescription that we provide out of the box. Now at the bottom, like you can go and see a little more detail into which exact row was being duplicated and how many times it's being duplicated. If you keep scrolling down, we also give you anomalous samples. So this is basically at the row level. So meaning you're always going to have some rows, right, or data instances, right, within your data set that are basically outliers. So in this case, you can see that this particular row is an anomalous, right, data instance. We also give you a score, and then we give you this list, which is basically ranked, sorted list of all these different rows that are anomalous samples, right? So this is basically computed based on isolation forest algorithm. So usually, a human in the loop sort of step is involved to manually inspect this. Subject matter experts, or if you're very familiar with the data, you can go and inspect this these individual data instances and figure out why this got added in and why this is anomalous, right? And take an action afterwards. Right at the bottom, you can also see the distribution or the class balance, right? How it is balanced. In this case, it's binary classification. You can see how it's actually split by proportion. Right at the bottom, you keep scrolling. We also give you options to basically run something called a quick model, which is a random forest classifier that gets built just using the raw data set. So we're not going to apply any transformations. So we take the raw data set and see how we can come up with a predictive model. And here you can see that it's just a perfectly fit model. The reason being, we still have a lot of things that we haven't fixed in our data set, right? So basically what you get out of quick model is it could be a really good model that you get out of it, but you would have to make sure that there are there are certain things that you would have to fix in your data to make sure that it's not a model that is
I mean,
unstable.
it's a proof that the target leakage that you have up there. That,
Correct. Yep. Now, right at the bottom, you're gonna see at the individual feature column level, what's the prediction power of these individual column. Like for example, for the target leakage column, you can see it's one, right? So one is basically a perfect prediction power. So that's again very misleading because reservation status just directly correlates with the target label. If you keep scrolling down, you'll see that there are certain columns which are barely contributing to the prediction power. So that is something you'd have to take care of. You can also look at two things individually again for every feature column. The overall frequency distribution of the different value counts, right, within that feature column, and also how that correlates to the label frequency, right? So you get that again at an individual level. So if you, for example, if you see here, there's a reservation status date, so you can see frequency distribution of that particular column and how that basically maps to the label frequency. And again, we show it for the positive case here. So in this case, positive meaning that there'll be a cancellation.
so based on all those insights, Aaron, how would you go about if you wanted to understand a bit more first, what other options you have for analysis, and then how would you go about feature engineering those using Data Wrangler?
But let's say I look at the data insights, but I wanted to do a little bit more. Maybe I wanted to go and create my own visualization, right? So to do that, click Add Analysis, and that's going to take you to the analysis page. Now under Analysis, you can see we give you built-in visualization options. For example, you can go and create histograms out of the box. You can also go and create scatter plots. We talked about multicollinearity. We talked about some advanced analysis types like feature correlation. So you can go and actually apply feature correlation, choose the type of correlation type. You can also go and create quick models. So Data Insights gives you a quick model, but let's say you want to create quick model at any point of time, right? During this process, because it's highly cyclic. You can always come here and create quick models. You can even go and bring your own custom visualizations in the form of code. So we support Altor as a framework. So you would have to write your Python code in Altor, and then you can bring that in here and create your visual custom set. And every time you create an analysis, you can go and actually save that, and you can go back to it. Now let's go and start doing feature transformations. So let's go back to the data flow. So we looked at the data insights. We definitely know that there's target leakage that we need to fix. There's also some duplicate rows that we need to drop. Now let's see how to go about in fixing these problems with the data set. And also we'll see how to go and actually normalize and standardize some of the categorical and numeric columns within our dataset. So to do a transformation, we'd go and add transform. So once you do there, you can go and actually add steps. And when you click add step here, you can see there's a lot of options that you can choose from. So basically all the transformations, the 300 plus transformations, are grouped into buckets here. It's like balancing data, encoding categorical, featureizing datetime. So there's a lot more like group by. Let's say you want to go and actually aggregate some of these columns, handling missing values. Let's go and start with some of the simplest things you could do. So we want to go and actually drop some of the columns, right? So we want to drop the target leakage. So let's go and you can also search for the transformation. So I'm typing drop here, so that's going to basically show all the options that allows you to interact with the columns. So I'm going to go and choose manage columns. So in manage columns, you can see there's a drop column transform. So here I'm going to say I want to drop the reservation status because that was the target leakage. So hit preview. So that should have dropped the reservation status, and then you can go and add. Now if I go back, you can see that we have added one more block because we added the transformation here to drop the column. Now you can click on add transform again, come back here and keep adding more steps. So let's see how to basically go and fix a missing value. So in this data set, we have the country column, which has a lot of missing values. So now to fix that missing values, we can go and say, I want to go and choose the country column. In the country column, I have, like if I go and scroll to the country column, you can see abbreviations for different countries, right? Now for the missing ones, where you don't have an entry here, I want to go and actually replace it with PRT, which is Portugal, given Portugal is the most frequent in this column. So I'm just going to make an assumption that if it's missing, it's going to be Portugal. So I'm going to go and type PRT here. I'm going to go and preview. So now we just saw how to handle missing values very easily. Not only you can fill missing, but you can go and actually apply different imputation strategies for handling missing values. But let's say I want to go and fix a missing value for a particular column, but I don't have it here as part of the missing transformations, right? So like I have impute, fill missing, add an indicator for missing and drop missing. But let's say I wanted to handle the missing value in a different strategy. Now how do I do that? Like if you go back to the workshop, so all that we're covering here in this session is basically covered in this workshop. So you can go and look at all the different more options here, and you can apply them, right? If you wanted to apply them. So let's go to feature engineering. Under feature engineering, let's go to handle missing values. So we saw how to use the pre-built transformation to handle missing. But let's say we want to go and handle missing values for this column, which is the meal column, and we want to go and bring in our own strategy, which is we're going to say for anything that's undefined in that column, we're going to basically write our own code as a custom transform. So in that case, you can go and copy the snippet here from here, go back, add a step, and right at the top, you'll see the custom transform. So here you can choose custom transform. So let's call it handle missing for meal column. That's the name for this custom transform. And then I'm going to choose PySpark and then paste that snippet what we copied here. Now this is going to go and say that, for the meal column, every time you see the meal as undefined, I'm going to go and actually replace that with bread and breakfast. Preview and add. You can also go and normalize, all your numeric columns, which is a very essential step in page engineering. So let's go and see, what are the transformations I have available for processing numeric. So under scale values, you can see, there are different scalar options. I'm going to choose the min-max scalar, which makes sure, which normalizes all the data, numeric data to be values between 0 and 1. So here for the input columns, I'm going to choose some of the numeric columns. Like for example, here I have lead time, right, which is a numeric column. I also have another column which is ADR, which are basically numeric in nature. I want to go and actually apply this scalar, min-max scalar on these columns. Hit preview, and I can add it here. Similarly, you can do that for categorical. So there's encode categorical option. Let's say I want to go and apply one hot encoding for your categorical columns, things like meal, market segment, customer type, deposit type, signed room type. There's like 5 categorical columns. So you can go and actually add in the input columns, and then say I want the output to be new columns, right? Because I'm doing one hot here. So you preview. Now it's going to go and actually apply the one hot encoding on all of these 5 columns. So if you scroll, you can see that it's already creating these new columns derived of that original categorical column we had. Click and add here. So far we've done, we saw how to do analysis, we saw how to look into data analysis. We also did some feature transformations, right, based on some information we got out of exploratory data analysis. Um, so you can see this flow file is expanding. Now we're getting to a point where I've created the recipe, or I've created the sequence of steps I need to take my raw data and get it to a final state. Now, how do I go and productionize this recipe, or how do I go and export the output of this pipeline that I've created here visually into a destination, right? Destination sync.
Also, Arun, I was just curious, like now that you've created you understood the data, you created a set of feature engineering feature engineering steps. How do you reach this job into terabytes or zettabytes of data? Like, how can you, so the sample that you took at the beginning, go into a huge scale?
Perfect. I think that's a great question, Costi. So here, everything we've done so far, right? All the analysis, all the transformations we applied was using the 10,000 random sample, right? That we queried from the original data set, which is 10 times bigger, which around 120 120,000 rows. But let's assume that in a real world scenario it could be even bigger, right? So we could have like a billion rows. Now, how do I take whatever I've done here, right, in the form of transformations, my one hot, my min max scalar, how the way I handled missing values, how do I scale that on this larger data set? Now, to do that, uh, Data Wrangler gives you multiple options. One of the first things you can do is you can go and actually create something called a destination node. So click on this button here and add destination. So today we offer Amazon S3 as a destination node or a destination sync. So when I click on that, you can see it's asking you uh, basically a name for your data set. So I'm going to call it transformed. And then I'm going to say I'm going to just basically pick a location for my data set, right? So I'm going to say I want the data set go to the exact same location, or maybe let's say this folder here, right? Booking. So that's why I want to store the output of this pipeline. So you enter all this value, add a destination node. When you do that, basically, it creates this destination node. Once you've created a destination node, you can go and actually create a distributed job, right? By clicking create job here. And here, so choose the configurations for your job, and then you can kick off a processing job just by hitting the button, run button here. So that will launch a distributed processing job behind the scenes that will take the same recipe and apply it on a larger data set. Now, this is one way to do it. Now, you can always go back to the same data flow and click on this, this plus symbol here, and you can see there's more export options. Now, by going through this export options, you can see, you can export all the steps you've done so far into S3 again through a notebook. Meaning, when you click on that, it's going to go and generate a notebook, and this notebook is executable, meaning you can go and modify a few things here. Like, for example, let's say you want to go and point to a different location where you have the larger data set. You can go and change that, and then you can even go and change everything we did right through the user interface previously for the destination option. You can go and actually change that here and run this notebook, right? So that's one way to do it. Now you can also go and export this as a pipeline. So this is the SageMaker pipelines options we talked about initially. So now this will basically take the feature engineering pipeline that you create in Data Wrangler, and when you execute this notebook, and convert that into a orchestrable, full-fledged end-to-end pipeline, right? It's going to have only the feature engineering pipeline, right? One single step. But let's say you want to bring in more steps, because you wanted to go beyond like feature engineering, and then bring in like training and deployment and all that. You can integrate it right with SageMaker pipelines, that way, by executing this notebook. You can
That's
also
great.
go
I
on.
think you can export it in many ways, but I know we are running out of time, and I saw a lot of questions on the chat, but I want to give more time to the folks to give us questions. Maybe, Arun, I really appreciate all the demo, working us through the exploratory data analysis, bringing for data from different data sources, do feature engineering pipelines and the steps that you added, and then in a way scaling into zettabytes and terabytes of data. And I want to close us off here. First of all, I'd like to thank you immensely for the time. This is really great to have such participation. Please keep asking your questions on the Q&A box. We have a lot of moderators helping. And if you want to run these demos for yourself, use this QR code or this shortened link to get to the workshop that Arun described. And if you have more questions, just email us. You can directly access our team through the low code, no code ML at amazon.com. So we love you to test it out, love you to give us feedback. So feel free to do both, but in the interim, ask your questions. Again, I really appreciate your time, and Arun, that was a fantastic session. Thank you so much.
Thanks everyone for joining today's session. Take care.